we are now under the heading of covalent bond, right? So we had ionic and covalent, and under that subheading of covalent bonds, there's two types of covalent bonds. And again, guys, we're like making this like cut and dry, like it's one or the other. Really, it's kind of a spectrum, but this will give us at least something to put some language to what we're talking about. Okay, so there's the polar covalent bond and the non-polar covalent bond. Now, polar, when you think polar, you know about the North Pole, right? There's a North Pole and the South Pole in the Earth, like it's the opposite sides of the Earth. It's kind of the same thing for polar. We start to have a separation of charge because our electrons are going to be shared unevenly, or sometimes you might write unequally between these two atoms. Now, covalent bonds happen. Ooh, I wonder if we should have written that before. Maybe slide back up on your notes. Let's just write yourself a note. We might be saying it later, but it's better to say it extra times. Covalent bond happens between two nonmetals. Okay, so remember our nonmetals are on the right side of the periodic table, and hydrogen, that's going to be a covalent bond, where an ionic bond, you need a metal so that it will give away the electron, and then a nonmetal to, ooh, that's nice, well, non-metal to pick up the electron. Okay, so maybe go back up and add that on it. Okay, so anyway, in our polar covalent bond, the electrons are shared between those two nonmetals. I don't know where I went. Maybe I'll just be in hiding here. You can't see me. It's fine. What happens when they're shared unevenly is that you get a partial positive and a partial negative charge. Oh, there I am. Okay. To say partial, it's not like we completely transfer the electron. That would be an ionic bond, right? Where we gave the positive charge completely away or picked up the negative charge, whatever that would be. It's a little bit, like the electrons are spending a little bit more time by this atom and a little less time over there. Okay, so the partial word in that is important, so maybe we should underline it or highlight it. And to say partial charge instead of full charge, we use this little delta symbol, okay? It looks kind of fancy. It's basically like you're writing an 8, but you just stop a little early. Okay, so it means partial positive, or like writing an 8, stop early, partial negative. So obviously this one has the negative sign, so that one is going to have the partial negative charge, where this one is a partial positive charge. Okay, so for example, I'm going to scroll down to this picture here. I can't get the new, they updated the app and I don't know how to run it anymore. This is a polar covalent bond over here, and so we can't tell from this picture, but let's just pick one for now. Let's say that this one is the more negative side. It does appear that way, right? It looks like the electron cloud is maybe over there more, and this is the partial positive side. Okay, it's called a polar bond. Sometimes people will write a dipole arrow. That always, oops, I did it backwards. That always points toward the more, no, I didn't do it backwards. Points towards the more negative side. I had to talk myself through it there, and then we put like a little plus on the other side. So the positive side of the dipole arrow is by the more positive side of the bond. It becomes more positive, why? Because the electrons aren't spending as much time there. Okay, so these two little things, these called delta. It's a lowercase of a Greek letter delta. You might know capital delta is a triangle. Those or the dipole arrow pretty much do the same thing. Okay, so polar bond, electrons are not shared equally. You've kind of got this like tug between the two atoms. One is attracting the electrons a little more, has a little more what we'll call electronegativity, and it ends up with a partial negative. And then another part of the molecule isn't getting the electrons as much and ends up with a partial positive. Okay, and then nonpolar is kind of the converse of that. If the electrons are shared evenly, then we don't get these poles. We don't get the positive and the negative part. There are no partial charges. Okay, so here in our nonpolar covalent bond, the electrons are evenly distributed throughout. So maybe we should write down electrons, even, wow. Oh, I have no idea what you're seeing right now because the whole thing just moved. Electrons evenly, should we say spread throughout? Let's just go with that today, spread throughout. I know you can probably not read that because I'm writing at a weird angle. Okay, covalent, sharing electrons. Polar covalent, not sharing evenly. Non-polar is that we are sharing those electrons evenly and we don't have any partial charges. I feel like this video was kind of all over the place. I'm sorry, but we're just going to keep it anyway.